So in the last video, we looked at uh, trying to improve the models that we've been working at previously. So we're trying to predict credit card balance based upon characteristics of the credit card holder, of the customer. And that we started with a very, very simple model that was a simple linear regression, that the balance is based upon a straight line relationship between the intercept, a slope, times rating. And that model didn't perform very, very well. Now, I should actually just scroll back here and just show you what we had there. We had a model that looked like this. Here was rating. Here was the balance. Yes, balance increases as the rating increases, but it's widely scattered, and our predictions were totally unsatisfactory. And so we endeavored to improve the model by including more information about the customer. We don't need to just use their rating information. So we drew upon other data and looked at credit limit and settled on income as the next best thing to add. And we took from our initial model, which just had rating, and it made predictions that were, say, within $200, $250, to one that included income. And we found that the model was better. Its standard error was 162, which meant that don't be surprised if your forecast is off by $162. Maybe even more, maybe even twice that amount. But usually it's going to be less than $162 away from correct value. And for those that like to talk of this magical R-square, it was 87.5%, suggesting where our goal was to explain 100% of the variation among customers, and we're almost there. We're at an A-level performance of 87.5%. So that's great, but it may not have been perfect. We did have issues that we noted because of interaction between rating and income, so that we ended up having a negative coefficient for income. We discovered that after you took account of the rating, then when you went to look at income, there was a negative pattern there. We tried to add a third variable. We added in age because it was the next best one to work with, and ended up that our standard error was still around 162, and really our R-square was practically unchanged from what it was before, so that we weren't making any additional progress. And what we'd like to do now is look and see, well, what other ways can we try improving it? Now, previously we'd been looking at residual plots to give us some insight and correlation of residuals. We didn't focus so much on the pictures as looking just at correlation of what's left over, what's the residual. But notice this residual plot for rating, that it sort of, if I ignore the stuff up above, it sort of has a dip to it. It goes down and then up and flattens out. That maybe it's not a straight line. Okay? So we could look at other things. We've got two things here. One is, what's that cluster up there? And why is this curvy? Here we've got a bit of a cluster. Here I'm not sure what we've got. So there are two things we can look at. My model, I've assumed, is a straight line model, simple additive type of model. This type of thing, where it's an intercept plus something times income plus something times rating plus 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 plus. So it's a very simple linear relationship. What if it isn't? That the other is I've got other variables. What's the marital status? Is the person a student, or males or females? What's their ethnicity? So there's some qualitative information I've not used yet. So there's other information not used because it was qualitative. And then my restriction on it being a straight line. So let's first look at the curvy part. So Nonlinear means there's a curve. So here was my initial information about borrowing increased as the rating increased. But if you look at it, it's sort of like flat, slopes up, and then it slows down. So it's like a twist to it, and maybe two of them. Here we couldn't see that so well. Maybe you can. It goes down, up, and then sort of down again. That in this one I could see a little better. It went down, up, and sort of flat. So there's some curvature there. How do we deal with curves? There's a lot of different ways. We don't understand what's going on. I don't have a theory as to what the relationship is between rating and balance in a curved fashion. So I'm just going to do a simple way and just say, give me any curve, a simple curve that fits through the data. And if that's what you're looking for, then think about two things. How many bins are there in the data? So if I go back, here's this one I like the best. It seems to show a curve this way, and then it sort of curves back again. It looks like it has two bins to it. It's got definitely one and maybe a second one. Well, that if you've got curves, you might want to use a polynomial like x squared, x cubed, x to the fourth, that type of thing. If there's one bend in it, try putting in a square. If there are two, put in a cube. Trouble is, ratings are big numbers. They go up to 1,000. Square it, and you're up to 1,000,000. Cube it, and you're up to billions. So the numbers get super, super big. And they distort things. It's really hard working with some numbers that are small and some numbers that are super big. So very often, when you've got variables that are of different sizes, then scale them so that they're of a similar size. And the most popular method for scaling is to find a z-score. So with ratings, take the average rating, divide by the standard deviation of the ratings. And z-scores tend to be between -2 and +2. Sometimes down to -3, maybe even -4, sometimes up to +3 or even +4, but almost all the values are between -2 and +2. So if I square it, I'm going to go from 0 up to +4 in most cases. If I cube it, I might go from -8 to +8. So they're not big, big, big numbers. They're not, their scale isn't crazy. So that's what I've done. So let me zoom in so you can see first off what I did with the data. I didn't bother with age because I didn't think age was useful before. So I've got income and rating as the variables I wanted. But now I'm going to scale rating, okay? And particularly for the square and the cube. I'll keep the original rating, but for this curvy part, what I did was I created a z-score for rating, and then I squared it. So I had, for this first one, the rating was 283. That ended up with a z-score of minus 0.46. Squaring that gives me plus 0.21. Cubing it gives me minus 0.1. Okay, so I've got now new columns. So here are my variables. They're going to be income, rating, z rating squared, z rating cubed, and then what I'm going to predict is balance. And I put that into my model, and this is the result. My R square before was 0.875, now it's 0.893. A little tiny bit bigger. My standard error, what? That's what this is. It was 162, now it's 150. Okay, a little better. It's changed all my coefficients. The coefficient for income is different, for intercept's different, for rating is somewhat different, and it's got all these funny ones for these z-scores that I've got in here. And if I look at my plots for income, it's pretty flat, which is the way I'd like it to be for my residuals, but I've got these odd people up above. I'll have to deal with that. For rating, it's still twisty, but it's tighter. It's not quite as bad as it was before, and it's still got these odd guys up above. And then I get this odd thing for these guys. I don't know what to do with them. So I've done my little bit to try to take curviness out, and it has improved the model a little bit. That these are relevant terms to add into the model, but it's still not perfect. I've got some strange things still going on. So what can I do next? Well, the other bit is, how do I deal with these odd things here, these odd residuals? So there, I'm going to want to look at my qualitative variables. So these are categorical variables, and that if some of them are binary, you're a student or not a student, you're married or not a student, married, you're male or you're female. I do have one that's ethnicity, that has people being Caucasian, and I've got ones being African American or Asian. What can I do with them? Well, what I could do with those is say I could have, I'll have a base case, and that'll be you're Caucasian. I'm trying to make these into numbers. That, but I could then create new variables. I could have African American, okay, is equal to 1 if you're African American. This is US data. This is their language in that regard. That, but it's equal to 0 if not. If you're not African American, you're Caucasian, or if you're Asian, then we'll make it 0. And then we could have another variable called Asian that's equal to 1 if you're Asian, and equal to 0 if not. So if you're Caucasian or you're African American, then the Asian variable would be 0. So with these qualitative variables, if it has many different values, I'm going to have to create a lot of new variables to be able to deal with this. But before I get into all of that type of work of trying to take words and make them into numbers, do I need to do this? Is there really any pattern? So what I've done is I've taken, and let me, before you see my pictures, oops, there are my pictures. Look and see what I did here. I took each of the observations, I got my residuals, that's the important thing, and then I just grabbed these other variables I had of gender, student, married, ethnicity. Okay? And for the residuals, I created a box and whisker chart. If you remember what that is, I went and I said, insert, recommended charts. I didn't like that. I went to all charts, I went to box and whisker, click that. And this gave me a chart of all my residuals. And you can see most of them, that's where the box is and the whiskers are pretty ordinary. And then I've got outliers. And this is the stuff that in my residual plots before, that I was having before, like these ones, were these, the ones that were hanging around outside of everybody else. So these odd people. Then I went to select data, and I went here to edit, and I picked one of my other variables, like gender. I put okay, took a minute, probably more than a minute because I grabbed it the wrong way. There it is. And it's got gender, male. I shouldn't have picked the heading of gender, excuse me, but male, female, and so on. And if I click OK, I now get a box and whisker for male and a box and whisker for female. Because I grabbed the labels, it's got this odd box sitting over here. I shouldn't have done that. But male and female look to be about the same, and they both got a bunch of residuals. So I did that for each of these variables. So let me just get rid of this picture here and see what did I find. So if I did it versus gender, I found, yeah, nothing seems to be happening here. If I looked at marital status, doesn't seem to do anything. That married, yes, no, that most of them are in the middle, and I've still got my funny outliers. When I did it by ethnicity, the three that I had, same pattern again. It's that didn't seem to account for any differences. There's no pattern here, so there's no new insight that I'm getting from it. But if I go up here and look at student, my outliers are almost all gone because they're sitting here. My outliers are the students. And the ones that are not students, they're the main box. Just look across and see these guys. The ones that are sitting way up here that are up at 400, 700, whatever, these outlier points, they're all students. And then there's a little bit of overlap here. So let's take student and make it into a numeric variable. I'll make it into zeros and ones. So that's what I did. I took income, rating, I had my curvy stuff, and then I used a lookup to go and take student, and if it was no, it made it a 0, and if it was a yes, I made it a 1. So I just used a simple VLOOKUP to create this, or an if statement actually, to create this variable. And then I had balance. So I've just added in this extra variable. And then I did my analysis. And look at my R-square. I've gone up to now 0.9679, like 0.97. I'm 97%. I've got a big A plus grade on this. This is really good. I've gone from a standard error that I had before that was 150 down to 82.8. So a big, big reduction, almost cut it in half. And now the terms in my model actually don't change very much. That if we went back here, if you can try to remember these, look at this, the minus 9 for income, plus 4 for rating, and then 78 and minus 18, minus 9 plus 4, 81 minus 21. They're almost the same numbers all the way across. Now my intercepts changed a bit, but even that not hugely. But then I've got this big number here for student, 417. What that says is that if I had two people that had the same income, same credit rating, but one was a student and one was not, I would expect the student to borrow $417 more than the person that was not a student. So this is a big deal. And how has it helped my model here? Well, I don't get much of a plot here. This is 0, 1 for the student, so it's not really telling me an awful lot. But look at my other ones here. Look at rating. It's still got maybe a twistiness to it. It's sort of got gaps here. I've got an odd spot down here. You can see it. I got a little cluster down here. I don't know what's going on with them. But the rest of it is now much more even around the line. And if I take the one I had for income, let me bring it down here so we can see it. There's so many of these guys. And make him bigger. This is a nice scatter centered around the line, but I've got 4 or 5 points down here. They're a little bit odd. So these ones seem to have low income. They have low credit ratings, but I'm getting odd predictions from them. These are ones where they seem to be carrying a much bigger balance than they should be. So maybe those ones are worth investigating. Those are definitely unusual customers and warrant some further study. But if I go back then and look again at what I've got for a model, that if I was to write it all out for you and say what my final model is, I'd be saying that my estimated balance is equal to minus $687.67. I want to be that precise. Minus 9.41 times the income in thousands of dollars. I had two customers, and one customer earned $10,000 more than the other. 10. Income is measured in thousands. Then I'd expect the one with the higher income would have a balance that's $94 less. Strange, but that's because it's correlated with rating. I've got then 4.31 times rating. So if your credit rating is 10 points higher, your balance is $43 higher. If it's 100 points higher, then it's $431 higher. I've got these funny things, plus 78 times Z rat squared. So that tends to be a number that's fairly small. It's around 1 in many instances. So it's got a big coefficient, but it's probably only increasing by maybe $78. And then I've got minus 18 times Z cubed. And again, those tend to be, if you're looking over here, relatively small numbers, often around 0, maybe +2 or -2, something like that. So it's not a huge impact. And then the big one is $417.39. You're a student. You're a student, you're going to carry a lot bigger balance on your credit card. And that's an important piece of information that we've just discovered here. So separate from all these other sorts of things. And that's about all I can get out of this data. If I went and looked at my residuals and tried to look and see, is there any further way to explain them based upon other things, I'm going to find there isn't much I can do. My R-square is almost at 100%. My standard error may still seem large at $82.84, but it's going to be hard for me to get it much smaller than where I am. And we're all done. Okay, so